Today we are covering section 72, graphing linear equations, and we're using a table, or X and Y charts, a table. Today we're looking at the table method. Homework is 7.2, page 311, 1 through 27 odd. Vocabulary for the day is graph and table. Take a minute, pause the recording, and please write down these rules. Now let's just discuss them. Number one, when you are graphing, these are must things to do. Number one, you must always label your X and Y axes. Number two, when graphing, it's very exact. So you have to use a straight edge. A Starbucks card, an old hotel room key, your school ID, these are all items you can use as a straight edge if you don't have a ruler. Sometimes carrying around a big ruler is a problem. Number three, always write on the line. So if you have graph paper, when you're drawing your lines, it should be here on the line, not in the middle of the line. Okay? Not doing this. Oops. Not doing this. Every time you draw a line, it should be on the line. Okay? Okay, so when you write the axes, the x-axis and the y-axis, it should. Okay, number four, no baby lines. That means this. If I'm drawing a line, I don't want to see your line go like this. This is a baby line. Okay, your line that should always cross the x and the y-axis and be the size of the graph. That's a baby line. Should always see it crossing the x and the y-axis and be the size of the graph. No more than one line per graph. Okay, so when I'm graphing a line, I don't want to see I just don't want to see more than one line per graph. So if we're talking about one equation is here, we don't want to see the other one being here. Okay? This one right here, it needs to be on a whole nother graph. No more than one line per graph. Okay? Let's go. All lines have arrows on both sides, including the axes. So you'll notice I just did that really quickly. I have arrow here, and when you don't do it, I knock a point off for that. So you need to be on your x-axis and on your y-axis and on the actual line. Okay, because what we're graphing goes on and on forever. And if you don't put those lines, it doesn't mean forever, infinite, all points included. Number 6 and number 7. The table, the work, and the graph have to be together. So, meaning, I don't want you to put all the graphs on this page and then put all the tables on this page. I want to see the table and then the graph. And let's say you're going from 2x plus 3y equals 5. I want to see any work, minus 2x, 3y equals negative 2x plus 5. This is not really the table that goes with it. And then I get y equals divide by 3, divide by 3, divide by 3. So y equals negative 2/3 x plus 5/3. And then whatever numbers you're filling in here, I want to see this all together. This tells a story, and I need all three parts together. Meaning, don't put all your work on one page and all your graphs on another. It always has to be together. I can't read one without the other. If I have to turn pages to do it, I will not give you credit. Okay. Label at least 2 points on the line. with their point numbers, meaning whatever the points are, I don't know, 2, 3 or 4, 5. Those are the wrong numbers. I'm just giving you examples. Okay. Don't number the axes if they increase by 1. We assume that they are. Choose multiples of the denominator for your x's. I'll explain that. Choose multiples of the denominator for your x's. So, for instance, which I will go on to, if your equation is y equals 3/5 x plus 2, in your table, you're going to choose multiples of 5. 0, 5, negative 5, negative 5, 0, 5, 10, that kind of thing. Multiples of the denominator. It will give you whole number points. All right. Points will be taken off on quizzes and no credit on homework if you do not follow these rules. Okay, we will make them habitual. That is the work that I need to get out of you. So, let's get started. All right, graphing linear equations. You don't need to write these notes right here. When we have one variable, we solve it, we get one solution. Okay? When I have when I have something that's x squared, I would have two solutions. But when I have two variables, okay, if x is 1, then y is 4. If x is 2, then y is 3. If x is 4, we have infinite solutions. Now, these solutions we can turn into ordered pairs, or we can actually put them in a table. The first of them is the x, the second in the ordered pair is the y. So the idea is that last week we were working on one variable equations. Now we're on to two, and so there are multiple solutions. There's three things we need to learn today, okay, that you're going to do in your homework. The first is to determine if this is a solution. And to determine whether it's a solution, we have to substitute the point in. Okay, so I'm going to substitute 8 and 3. Substitutes in, 8 plus 3. We simplify that to 11. Is that equal to negative 5? It's not equal to negative 5. So 11 is not equal to negative 5. That's how I want you to show it. And so you're going to say, no, it's not a solution. If these come out equivalent, then it's a solution. Okay, pause the recording and try 2, 3, and 4. All right, let's check our work. We substitute in 8 minus negative 4 really becomes 12 is equal to 12. I would like you to go all the way down. So 11 is not equal to negative 5. I would like to see 12 is equal to 12. So it is a solution. I want you to finish it. Okay, 13. My x is negative 7 and my 6 is y. Remember, the first letter is the x and this is always the y. Okay, so I'm substituting negative 7. That becomes a 6 equals 6. So that is a solution. And next I'm substituting. 5 goes for x and 1 goes for y, and we're going to see that would be negative 4, and that's positive 6, so it's not a solution. Negative 2, sorry. Not a solution. All right, we can pause it and try it again. Let's see if the following are solutions. Now, we can still put in our fractions. Let's check our work. I'm really only going to go over one of them. So 6 minus 1, is that 5? Yep. So that is a solution. is 3 times 4. I'm substituting it in. 3 times 4 is 12 minus 5 is not a solution. Negative 3 for the x, so that would be 6. Negative 6 plus 14, it's still not a solution. Wait, sorry, negative 9, whoops. It's morning, here we go. Negative 9 plus 14, that takes 5. Yes, it is a solution. Okay, I want to go over this one because I know a lot of people have a hard time. So the original equation is 3, right? I'm going to substitute in the fraction. 3 times 1 over 2. You have to put that in parentheses. Minus y, which is, I'm going to convert this to a mixed number. That's 6, 7. Minus in the problem and a minus here, so a negative here, so it's minus minus, double negative, 6, 7 over 2. So we get 3 over 2 plus 7 over 2. That makes, is that equal to 5? Is that equal to 5? That's 10 over 2, and is that equal to 5? Yes, it is. 5 equals 5. So, yes, it's a solution. Pause the recording if you need to look at that further. Okay. Next one, negative 1. That would be negative 3, and negative 2 makes negative 5, so it's not a solution. So that's part 1 of your homework. Part 2 is graphing the equation. Now, here's the thing. You choose your x's. You get to choose your x's, your x solutions. Okay? Now, my PowerPoint's going to show 6 points. I'm going to say you need about 3 points. 3 rules I liked in my choosing. I like to keep it low. I like a negative, a positive, and a 0. Okay? So I personally would start with my choices here would be I would want negative 1, 0, and 1. Now you'll see on my PowerPoint I'm choosing more. And so we'll do those, but you only need to choose 3, okay, when you're graphing. So now I'm going to substitute this in. I like to make kind of a 3-way table where I substitute I don't put my y here. I actually put it, move it over, I make it a bigger table. And, oops. Okay, I make a bigger table. Move this over. And I give myself room inside, so that's negative 6 minus 3 is negative 9. Okay, and that's an ordered pair. Negative 3, 1, 2, 3, down 1, 2, 3, 4, 5, 6, 7, 8, 9. It's off the graph. That's why I say keep it low. I really only choose these. So I'm doing 2 times negative 2 minus 3. It's negative 4 minus 3 is negative 7. So now I'm going negative 2 down. Here's 6. Here's, it would probably be here. It's still off the graph. 2 times negative 1 minus 3. So that's negative 2 minus 3 is negative 5. 1, negative 1, 2, 3, 4, 5. The one's probably over here, yeah, something like that. Because it has to be making a line. Okay, that's exact. So I'm doing 2 times 0 minus 3. That zeroes it out, so it's negative 3. 0, 1, 2, 3. Okay, and then I have 1, 2 times 1 minus 3 That's 2 minus 3 is negative 1. So now I have 1, negative, I'm going over 1 and I'm going down 1. I'm going to go a little bit further, 2 minus, 4 minus 3 is 1. So I'm going 1, 2, 3, 4. Sorry, it's 1, 2, up 1. Kind of starting to see it. Now that I've crossed my x and y axis, I'm ready to graph. You want to use a straight edge and make sure you connect the 2 widest dots, 2 furthest dots. You're connecting this one and this one. Make sure you put arrows that you've labeled your x and y axis. And now we're going to label 2 points. This point is 0, negative 3, and this point is 2, 1. Any 2 points. All right? Let's look at my PowerPoint. It'll look a lot cleaner. So this is where they started. But you really only need like these 3 right here. Now, we could choose a fraction. That's 3.5 when x is 3.5. And let's look what happens. Okay, it becomes 7 minus 2, it's 4. So it's really 3.5, 4. So I would move over. I'd start at the origin and I'd move over 3.5 and then go up 4. Move over, start from the origin and count 1, 2, 3.5, and then go up 4, and that's where I end up. You're still going to be on the line. Doesn't matter what you choose. If you substitute it in, it will work. Okay, this line with the arrows represents all real solutions. Anything you choose, anything that anybody chooses for this equation. And if you don't have the arrows, it doesn't include the infinite solutions. So my axes not only need to be labeled with y and x, but they also need to be labeled with arrows. I'm going to be checking your homework very earnestly. Now, this was very easy because y is alone. So we're always going to try and get our y alone first. Okay, this equation was very easy because the y was alone. Okay, so what happens if y is not alone? Let's use our inverse operations to get y alone. So I'm going to subtract 2x from both sides. Notice 2x and 5 are not like terms, so I'm left with y equals negative 2x plus 5. I always list my x term first. I want you to do that, okay? Okay, you try the next one. Try and get the y alone. All right, let's try it together. Instead of minus x, I'm going to add x. And then I'm left with 2y, so I have to divide. I want to split that. I don't want to get rid of the whole thing. Splitting it, so since 2 times y, I have to divide by 2, all terms. That means divide this, divide this by 2, divide this by 2, divide this by 2. And y equals 1 over 2, right? There's a 1 there. We don't really write it. 1 over 2, the x goes to the middle, minus 2. Okay, so getting x alone. But remember, when you're over 2, x is over 2 and 4 is over 2, so I separate it. Okay. All right, pause the recording and try the next 2 on your own. Okay, let's go. Let's check. We're going to subtract 3x. Notice here, I'm not dividing because I want to get rid of the whole thing and get y alone. That's my goal, to get y alone. Now I'm dividing everything by 5. y is divided by 5, negative 3x is divided by 5, and 10 is divided by 5. I don't think you have to do this many steps. I would just write the 5 under everything, right here and here, and then simplify to the answer. So y equals negative 3/5 x plus 2. Let's check our next one. I'm adding 2x. Divide all terms by 3. And y equals 2x over 3 minus 6 over 3, which is 2/3 x minus 2. Now we're ready to mix what we've been doing here and the table. Okay, so it's easiest to make the table if we get the y alone. We have one more step that we're adding to this. So step 1, we're going to get y alone. I'll subtract 3x from both sides. Divide all terms by 2. Again, they're doing so many extra steps. I would have just gone right to this. And we get y equals negative 3 over 2x plus 2. Now, if you have a fraction here, right here, I want with the x term, when you make your choices, you want to choose multiples of the denominator, okay? Choose multiples of the denominator. So since 2 is in the denominator, I'm going to choose negative 2, 0, and positive 2. There I have a negative, a positive, and keep it low. My graph is going to choose more. They'll probably start at negative 4. Yeah. So if I substitute in the negative 4, let me show you why you're choosing multiples of 2. Oops. Okay. And I would like, I'm going to make my own, hold on. I'm going to make space, and I want you to make your own table, a three-way table. Okay. And I just don't even, here, let's go here. There we go. Okay, I'm going to make it a three-way table. I'm going to give myself lots of room. Okay, and now I've got negative 3 halves x plus 2. And over here I'm going to get the y. Okay? Let me go in red. How's that? So let's do negative 2. Negative 3 over 2 times negative 2. Notice it's lined up. Over 1 plus 2. Okay, I'm going to, negative times negative makes a positive. This cancels out. I'm left with positive 3 plus 2 is 5. Negative 1, 2, 1, 2, 3, 4, 5. I plot the point. Okay, I'm going to start with 0, then I draw a line, 0. The equation is negative 3 over 2 times 0 plus 2. Well, 0 times anything makes this whole thing be 0, so it's 0 plus 2 is 2. Okay, so 0, 1, 2. There we go. Let's go to positive 2. Negative 3 over 2 times 2 plus 2. Now notice these cancel. Negative 3 and 2 is negative 1. So I'm start at my origin. It's 1, 2, down 1. Notice this is making a line. If you want to go one more, you can go to 4. Negative 3 over 2 times 4 plus 2. So this goes once, twice, Negative 6 plus 2. Negative 6 plus 2 is negative 4. So it's 1, 2, 3, 4 down 1, 2, 3, 4. How many points did I say you needed? 3. We could have stopped there. And then you're taking your straight edge, and you are, this is really hard on the iPad because it really goes, sometimes it goes exact. And then we always have to put arrows on our lines. I'm going to label this one, which is 0, 2, and I'll label this one, which is 2, negative 1, and I am done. So let's talk about it. We get y alone. Okay? And then if we have a fraction, we choose multiples of the denominator. I did that here. And then I have to plot 3 points. Make yourself a 3-way table. And that's it. And then we graph it. Make sure to label the x and y axis and put arrows and label 2 points. Whew. Okay. So again, I'm getting, what would I do? I have to get y alone, so I'm going to subtract x. Oops, didn't mean to do that. Subtract x. Divide all terms by 3. So you can skip that step and just divide all terms. Put the 3 under everything. Over here it cancels. So now, notice we are left with, this is a negative divided by a negative is a positive, and so I'm left with 1 over 3, and x goes in the middle or on top, right? Plus positive divided by negative is a negative 2. Now, what kind of multiples are we picking? Hopefully you've chosen negative 3, 0, positive 3. If we want to go one more, we'd go to 6. And I would make the 3-way table. Okay. Dividing by here. What multiples are we picking? Negative 2, 0, 2. So it's just more practice. How many solutions am I asking you for? 3. I'm asking you for 3. All right, so today we found a solution by substituting the point in, and then we learned how to get y alone, and then graph it using a table, picking 3 x's. And that's our lesson.